network infrastructures or IT infrastructures need to communicate with each other through a network. And we have different network components. In other courses, we learn about the function of a switch, a router, and probably a VLAN, virtual LAN, and some other network devices and network protocols. Today, we want to see how this can affect communication in a cloud computing environment, which is more or less a virtualized environment that deals with a lot of virtualization and virtual machines. So let's go through it together. Forward. In a network situation, you can actually have a number of virtualized physical network devices, and also you can have some virtualized infrastructure that communicate with each other using a server or using a router or a switch, basically. So this is the forward. You can have both physical and virtual network infrastructures communicating with each other in a network environment that deals with cloud computing. So in today's class, we will try to understand how a physical and virtual switches can communicate with each other, and try to understand also, try to understand the network architecture used for virtual environments, and understand traffic flows between virtual machines, and of course, try to understand the concept of VLANs or virtual LANs. So this is what we are going to learn in this chapter, inshallah. So the first section of the chapter will discuss about network architecture for virtualization. The second section, we will discuss about physical network for virtualization. Section 3 will discuss about virtual network for virtualization. And last but not the least is the fourth section, where we shall discuss about network features for Huawei virtualization products. So we will take the first section first, which is network architecture for visualization. When we discuss about creating virtual machines in a network environment, the first question that everybody will ask is, how will the virtual machines be able to communicate with each other? Okay, so this is the question that we will try to around in this section. But before we go into answering this question, let me ask the class if you have any idea how virtual machines communicate with each other. Is there any special features in the network that helps them to communicate, or is there any special protocol in the virtual machines or in the network environment that helps the virtual machine to communicate with each other? Do you have any idea how virtual machines communicate?
Virtual NIC.
Virtual NIC, right?
Yeah.
Excellent. What else? Okay. Thank you for this wonderful contribution. As we know, for any device to communicate in a network environment, the device need to have a NIC, which is network interface card, right? So you need a network interface card to be able to uh, allow devices to communicate with each other. I remember many years ago when we used to buy some desktop, we always have to go and buy a, a NIC separate before we can connect to the internet. Because if you have a machine and the machine do not have the NIC, that means that the machine cannot be able to communicate with you with other machines on the internet. But now things have changed. The NIC normally comes automatically with our devices. So nowadays, many people don't even know how the NIC look like or how what is the function of the NIC in the computer. They just simply buy the computer, it comes with it, and then you simply enable your device and connect to the internet automatically. So this makes many people not to or to forget about the function of this very important device. So in the virtual environment, we have what is called virtual NIC as I think Khalid is the one that speak, right? He spoke. Yeah, so NIC, virtual NIC helps the virtual machines to communicate. So this is the network architecture for visualization. A very good, uh, this is a very good topology that explains almost everything that we need to know about a virtual environment, especially in the concept of cloud computing. So what do we have here? At the top here, we have the router, okay? And then we have the layer 3 switch. Layer 3 switch is the switch basically that connects the router with the remaining network. And of course, we have layer 2 switch. This is a layer 2 switch. This is a switch that connects uh, other subcomponents of the network with layer 3 switch. Basically, this is a switch that connects devices within a subnet with layer 3 switch that connects the other devices to the outside network, basically. So this is what we have here. To explain this, we have also physical servers. This is physical server. This is another physical server. This is another physical server, and this is another physical server. Okay. In this physical server, you will observe that we have a virtual machine created. So this is a virtual machine. This is another virtual machine. Okay. And of course, this is another virtual machine in the other physical server that we have. So basically, uh, if the virtual machine here wants to communicate with the virtual machine here, it's easy. What we need to do is this virtual machine will simply send the traffic and it goes through the virtual switch and then it goes to the other virtual machine. This is easy to do because both virtual machines are connected. Oh, sorry, I didn't observe something. This line is connecting outside, basically. So I think this will explain it better. So basically, this virtual machine can communicate with this virtual machine within the same server via a virtual switch. Okay, but in this case, of course, as been drawn, it shows that this virtual machine is actually connected through another switch, which is a layer 2 switch. So it will be a little bit difficult to communicate directly with the other virtual machine within the same physical environment. However, so where do we have the NIC? That is the um, what do we call it? The network interface card. So this is where we have the NIC. Okay, the NIC is within virtual NIC in this case. A virtual NIC is connecting the virtual machine with the virtual switch. Okay, so It simply means a traffic will be sent from the virtual machine through the NIC and through the virtual switch. And then the virtual switch simply have to send the traffic, and then it goes to communicate with other switches, or I mean other virtual machines, or other physical machines, as the case may be. What else do we need to explain here? We need to explain that there are two types of traffic in a visualized environment. The first one is called north-south traffic, and the second one is called east-west traffic. Okay, so this blue line will help us to explain it better. So you can see for north-south traffic is a traffic that simply has to pass through the switch, or layer 3 switch that connects you to the router before communicating to another device outside of the network. Now let me explain again. Assuming we have another device somewhere outside of the network that wants to communicate with either of these, it means that the traffic coming from that device has to pass through the switch, right? Sorry, through the router, right? And then through layer 3 switch, and then it goes down to the layer 2 switch, and then of course it goes down to the virtual switch, which connects you with the NIC, or virtual NIC, to the virtual machine. And then the virtual machine also, after processing whatever information is received. Once the virtual machine needs to send information back to the outside device, it goes the same way. Basically, it goes through the NIC and send the traffic through the virtual switch. And of course, the traffic goes to the physical switch, layer 2 switch, and then goes to the layer 3 switch, and then goes to the router, okay, before going to the outside device in another network. So the fact that we always have to pass through the router before the traffic is being connected to the outside network or received from the outside network, this makes it actually a north-south traffic. It always has to pass through the router. Do you understand this concept?
Yes.
Not very good. So the main point that you need to remember is for a north-south traffic, the traffic always has to pass through the router. But you can have a traffic which is called east-west traffic. This east-west traffic do not have to pass through the router. No, because it's a communication between devices that are within the same network. Okay, maybe in different subnets it's okay. However, the traffic do not have to pass through the router, but it can pass through the switch, no problem, but not through the router. So for example, this virtual machine trying to send a traffic to another virtual machine in this other traffic. So it simply has to send the traffic through the NIC, through the virtual switch, and it goes out to the physical switch, and then probably goes to another physical switch, and then um, goes to the physical server that contains the other virtual machine. And then, of course, this physical server will have a virtual switch, which also will have a virtual NIC, which will have to communicate the traffic to the virtual machine. So this way, the virtual machines can actually communicate within the same network, even if they are in different physical server. And that means that this is basically an east-west traffic because the traffic do not have to pass through the router. Any question? No question. Okay, so let's see the next slide. Basic network concepts. Important things we have to remember are, in the case of a cloud computing environment, we have the broadcast and the unicast in one point. We have routing taking place also in another point. We have our default gateway, and we have also the VLANs. So it is important to remember in cloud computing for basic network concepts. So let's look at them one after the other. Let's see how we can explain this. So first question, what is a unicast? We can remember this. Unicast.
I remember it's something related to one-way communication or two-way communication, if I remember correctly.
One-way communication, very close. How about broadcast?
To everyone, to all devices.
Yes, basically, this is when you are sending a traffic or a frame, or you are sending a message, in the case of unicast, to only one person, or one device, basically. One device can be sending a message to another device. One other device is called unicast, right? Yeah, this is it. But we have another one that is not mentioned in this slide, which is called multicast. Multicast is when a device is sending message to many devices that are known. We already know the devices. For example, in your phone, you want to have a wedding, you have a number of phone numbers in your device, your mobile device, in the address book of your device. You can simply select the people that you want to send an invitation to, and you can send a broadcast, sorry, a multicast directly to this number of people. You already know them because you have their phone numbers. This is simply a multicast. But in the case of a broadcast, is you simply send this message to all people, known or unknown people. You don't know them, you know. I mean, you just simply broadcast it, and you will see that many people will receive the message. This is what happened with sometimes the network. I mean, we receive messages from ministries sometimes. This is a broadcast. They simply send it to all people. If there is an emergency, of course, the ministry can send messages. Sometimes if there's going to be rainfall, they send a broadcast. The broadcast will fall on everybody's phone. Everybody, known and unknown, they will receive this message. So this is a broadcast. So this is actually what happened here. Okay, if a message is sent between one virtual machine to another, this is a unicast. But once the message is broadcasted across and all other virtual machines receive it, that means that this is simply a broadcast. So unicast, one machine to another. Broadcast, one machine to all machines. Multicast, one machine to many machines that are known. So basically, this is the concept. So in the case of the second phase, this is where we discuss about default gateway. Anytime we discuss about gateway, the first thing that will come to our mind is that a router is involved, because that means that there's a communication between a network or our network and another network. And the fact that the communication is passing through, is going to another network, it simply means that there has to be a kind of routing that has to take place before that message can arrive at the other device in the other network. But now, of course, we are looking at virtual machines, okay? So we have our virtual machines, okay, which are of course inside a virtual server or a virtual device, okay? And of course, we have another virtual machine outside of our network, okay, which is also residing in another physical device somewhere or physical server. So that means that the communication between the virtual machine in this physical server to another one will have to pass through a switch. Okay. Likewise, if this virtual machine is to send information to other virtual machines, that means that it has to pass through the router, sorry, through the router. So if we want to look at a broadcast in this situation, once this machine basically sends the broadcast, it goes to all other devices, I mean, all the virtual machines in the other network. But the most important thing for a default gateway is that a router is involved. Anytime you hear the word gateway, it means we are referring to simply the router. The router is involved. So communication has to pass through the router. And the fact that is passing through the router, what type of traffic do we call this? Who can tell me?
What's the
Who can
question?
remember? Yeah, in this situation for a default gateway, a communication between one virtual machine in another network to another virtual machine that is within our network will have to pass through the router. I'm asking the question, the fact that
Uh,
the traffic has to pass through the router, what
North
type
south.
of traffic? North-south, very good. So this is a north-south traffic. So let's look
Doctor,
at,
for this, uh, like in corporate environment, usually we say like north south. It's like within the network and outside the network, like within like the company network and with the internet, and like west uh, east west is like within the company network. I don't know if this
excellent.
is like if this the same or
Yeah, it's the same. That's just what we explained in the previous slide. Let me take one slide back. Uh, you can see this is the company network, right?
yeah.
So all communication within here cannot pass through the router, basically. So this is called east-west. But the moment communication has to pass through the router, that means you are moving out of the company's network and the communication has to go through the router. So that's why we call it north-south traffic.
Okay.
So yeah, so you explain it in a different way, but it's very good. And it simply gives a physical reality to the explanation we just made. Yeah. Okay, so we have the routing. Routing, of course, takes place through the router. We always have a communication source, which is probably another virtual machine from another network. Okay, this virtual machine will have to send this information to various virtual machines, probably within different segments. So you can have a segment A of a virtual network and a segment B and segment C. So simply the router will route the information through these different virtual machines before a communication will take place. And of course, we cannot emphasize also the function of a NIC or virtual NIC that is installed or created basically in the virtual machines for it to be able to function properly or receive and send information uh, within the network. Then the VLANs, we know about the VLANs, virtual LANs basically. Virtual LANs For example, we have this is a physical switch, basically layer 2 switch. This is another physical switch, which is another layer 2 switch. Then we need to have a connection between two different switches before we can have communication between LANs that are on different switches. Okay, so this link between two physical switches is called a trunk link, basically. And trunk links receive and parse what we call tag frames. Okay, so tag frames basically moves within trunks. Okay, untag frames cannot pass through trunks, basically. So if it's an untag frame, it simply will not accept. So let's look at what happened. You create, let's say, a virtual LAN, and within the virtual LAN, you create your virtual machines. Okay, so then you need to have a NIC communicating your virtual machine or connecting your virtual machine with the physical device or the physical switch here. Okay, so let's say, for example, you have a NIC here connecting you to the switch. Okay, so the switch, basically this connection between a virtual switch or a virtual machine in a VLAN and a physical switch is what we call access link. Access link. So now I just explained two types of links. One is called the trunk link. The other one is called an access link. Access link basically connects a virtual machine, okay, and a switch, while a trunk link connects between two different physical switches. These are not virtual switches, physical switches. Okay, so of course, on the switch, you can have different virtual LANs. So what do we do with the VLANs? I mean, you can have different VLANs, and inside the VLANs, we have different virtual machines. So another thing that I need to explain is that for access link simply communicate what is called on tag frames. Now, an on tag frame is a frame, okay, that is being received by a virtual machine from a switch. Now, this is how the communication goes. You have a virtual machine here, okay, within a VLAN. Okay, let's say the VLAN is created for one department, let's say IT department. VLAN 2 is created for engineering department. VLAN 3 is created for HR. Okay, but in another switch, we have VLAN 1 created for finance department, VLAN 2 for management, and VLAN 3 is for English department on a different physical switch. Okay, so if the virtual machine that's being created here, okay, in VLAN 1 of switch 1 is to send a frame, it will send an untagged frame to the switch. Once the switch actually receives this untagged frame, the switch will simply have to tag it. Why? Because it has to send it to a trunk. So after tagging it, it sends it to a trunk. A trunk is the connection between two physical switches, and trunk only receive tag frames, receive and send tag frames. So it will send the tag frame to the next physical switch. So upon receiving this physical, I mean, upon receiving the tag frame by switch sent by switch 1 to switch 2, the switch 2 simply have to untag the frame before sending it, for example, to this virtual machine residing in another department's virtual LAN. So that's the essence of having tag frames, untag frames, and also the difference between access links and trunk links. Any question? Okay, so let's see the next section. Next section discusses about physical network for visualization. Physical network devices, we have the routers, we have the layer 2 switch. This is how the layer 2 switch look like. And we have the layer 3 switch. This is how it looks like. And then we have the server NIC. Okay, this is the NIC we just mentioned, the network interface card, basically. I guess this is just a familiar, these are familiar devices actually. But I want to ask the question, what's the difference between layer 2 switch and layer 3 switch? Hello. Who can tell me?
Layer 3 it works like a router, while layer 2 it works like just a normal switch, like a hub.
Yes, excellent. Okay, layer 3 switch basically connects you to the router, and layer 2 switch is just a normal switch that works within a local environment, basically. So let's go to this. How routers basically works in a visualized environment is what we are going to explain. Routers always connect us or our network to another network, or we can simply say to the internet. Okay, so you can have virtual machines sending information to the router, and the router sending this information to the another network, basically uh, within outside of our network, basically. And this is exactly what we call the north-south traffic that we explained previously. And of course, we cannot emphasize more that the virtual machine always need to have a virtual NIC, okay, which sends traffic to the router, okay, sorry, to the switch, and before sending it to the router, okay, so this traffic goes to the router, and then the router will simply send this traffic to the outside network. The same thing happens when this traffic is coming back from the outside network. So let's look at, so this is for router. So let's look at for switch, because we actually said router, layer 3 switch, layer 2 switch, and NIC. So we're gonna look at layer 3 switch now in a visualized environment. This is a layer 3 switch, as we mentioned. Yeah, so layer 3 switch can have a connection with your physical server. Okay, you can have another connection with other users. You can have a connection with storage devices, okay, like data centers. And we can have a connection, of course, with virtual machines. So all these connections basically can be rerouted through the router by a layer 3 switch. So this is the layer 3 switch, okay? Now, what we need to mention, which is very important here, is that the type of traffic that all these different devices that connects to the layer 3 switch handles, okay? A traffic between a layer 3 switch and a virtual machine is called service traffic, okay? So layer 3 switch can send a service traffic to a virtual machine and also can receive a service traffic to a virtual machine from a virtual machine. The connection between layer 3 switch and a storage device send and receive what is called a storage traffic. Basically, this is data information that is to be stored. A certain storage device, for example, a data center or any type of storage device that we have, basically. The connection between a layer 3 switch and a physical server can manage or send and receive what is called management traffic. So a management traffic is a traffic that moves between a layer 3 switch and a physical server. Last but not the least, we have what is called management and service traffic, which is a traffic that other users, me and you, can simply send and receive between ours and the layer 3 switch, or it goes to the router for further communication or the routing, basically. So these are the important things that we need to know about this. Then the next one is layer 2 switch. A layer 2 switch in a virtualized environment, basically, this is switches that simply manages what we call, what type of traffic? Is it northwest, north-south traffic or east-west traffic? Who can tell me?
East-west.
Exactly. Okay, so a layer 2 switch basically manages east-west traffic within the same company, or traffic that do not have to pass through the router, as we explained previously in the other slides. Okay, so you can have your physical service, okay, you can have your storage devices, you can have the users, and of course you can have management switch, you can have a storage switch, and you can have service switch. Okay, so now this is the thing. Each of these switches, okay, simply send and receive information from devices that we mentioned using either a management switch, a management, what do you call it? Traffic, yeah, a management traffic, or service traffic, or we can call it storage traffic, depending on the type of communication. Okay, so for example, service switch can communicate directly with users because it sends and receives management and service traffics. Okay, so of course, the service switch can as well send information and receive information to the physical server. Okay, the management switch can actually communicate with both the physical server, the storage service, and of course the users. What only differs is the name of the type of traffic that is sent or received, basically. Likewise, the storage traffic can send and receive information to storage devices, okay, and of course, also to physical servers. So this is what we need to remember in an east-west traffic situation. Then the physical NIC, as I mentioned before, is we actually have a physical network interface card that we used to install on our device before we can actually connect our device to the network before. But now all the laptops, all the desktops, they come inbuilt with the network cards. So therefore, we don't need to bother about that. We don't need to buy it separately to install it, basically. Unless, of course, if we are having communication problem between our device and the network, and then we find out that the problem is simply the NIC that is not working, so we can actually get another NIC and remove the one that we have and install it, and then you can simply find out that your computer simply just is now connecting to the internet or is connecting to the network. So this is another problem. And sometimes the NIC can actually move out of its port. Okay, if it moves out of its ports because of vibration or the movement. It can actually cause your computer not to be able to communicate with other networks or not to be able to access the internet. So sometimes when you just simply open your computer, you find the NIC and then you push it further and then it gets tucked into the port and then simply your network will come back. So these all are scenarios, okay? So now, we can have NIC in a physical environment and of course in the logical form. Okay, in the physical environment, this is simply how the NIC looks like, and mostly is an unbundled NIC. An unbundled NIC simply means it's a physical NIC. But of course, we can bundle it. Okay, NIC also can be divided just similar to what we do to a switch, okay, to create VLANs on a switch. So in a situation where we have one physical NIC and we have to segregate it into two different bundles of NICs in order to carry out or manage different traffics, then this is what we call a bundled NIC. Okay, a bundled NIC is just it's a single NIC that simply we have to virtually have to recreate it into different segregations, basically handle different type of traffic. So you can have a virtual NIC simply handling management traffic, create another virtual NIC that handles service traffic or storage traffic like this, okay? The protocol that we use to bundle NICs is called LCDP. LCDP full meaning is simply link aggregation control protocol. So that is the protocol that simply helps us to bundle NICs. And when we bundle the NICs can still be able to communicate with the virtual machine, okay? And of course, the virtual switches or physical switches as the case may be. Any question?
No, Doctor, thank you. Clear.
So let's go to the next section, virtual network for visualization. So we have mainstream virtual network, okay? Now we want to go back to our first idea, basically. The first idea is we're gonna have a physical machine, which is called also the host. In the host, we can now create our virtual machines, which are called what? Guest machines. So we have a host machine and a guest machine. The difference is a host machine is a physical machine, a physical computer, basically. But a guest machine is a virtual computer that you just created. So you can have a guest machine A, maybe a guest machine 2, a guest machine 3, like this. In this situation, in the guest machine, you also have to get a guest operating system. Okay, you can install, for example, an Ubuntu Linux on this guest machine, and then in the other guest machine 2, you can install a Windows operating system, and in the next guest machine, you can create a guest machine and simply install on it a different operating system. For example, you can say a Red Hat Linux. And of course, you have the libraries, which are Ring 2, and then the applications programs, okay? You can have all your application programs running on the operating system, the guest operating system, which is on the guest virtual machine. Now, the communication between the, sorry, I got something. Yeah, communication between these virtual machines, okay, will have to go through a virtual switch. So if this virtual machine want to communicate with the next virtual machine, it will have to go through a virtual switch. Okay, so and it must have a NIC, which is the virtual NIC basically in this case. So the virtual NIC sends the traffic, and then it goes to this virtual switch, and then of course goes to the other virtual NIC received from the virtual machine, the other virtual machine at the other end. Okay, so basically this is a communication within the same virtual host. But sometimes you need to communicate between the virtual machine and other virtual machines outside of the physical host that you have, which is the host machine basically. So this communication can pass through a bridge. Okay, a bridge helps to communicate with the virtual machines. Okay, uh, to other virtual virtual machines that are on different physical hosts. Okay, then we have this the fact that this communication is now going out of the physical host that we have. Some form of translation of the addresses is needed. That's when we need the NAT. The NAT is network address translation. It translates the addresses that helps to identify the position or the destination of traffic, basically. Okay, without the NAT, it will be maybe you just simply send an information, it will take forever before it can simply arrive because it has to go round and round. But with the NAT, address translation can be easy and simply it can identify the virtual machines that is needed to receive or to send the information that you are actually managing. So this is what we have in the main virtual network architecture. So the bridge versus the NAT, this is how it works, basically. So in the case of a bridge, this is a bridge, okay? So you send an information from a virtual machine, okay, using a virtual NIC, okay? So this will simply goes to through what we call a tap, okay, to the bridge, and the bridge can simply connect with the physical host before sending it out. But in the case of a NAT, the bridge having sent a traffic, instead of having a bridge here, you can have another machine that will receive this information, and then it will, this is actually also a virtual machine, then it will simply translate the address before sending it out through the physical machine. So this is the main difference. Here we have another machine that simply has to do the translation of addresses before sending it out to the physical machine. Virtual switch. Virtual switch uses what we call open vSwitch. An open vSwitch is a switch that helps to translate traffic between virtual machines and a NIC, okay, or a virtual NIC within a virtual environment, okay. For the purpose of functions, open vSwitch have a number of functions. One is it provides security. The VLAN isolate, it can you with this for security you can have VLAN isolation, traffic filtering. These functions can be provided with the open vSwitch. It can provide monitoring like net flow, S flow, span, and R spans. And also it can provide quality of service, QoS. Okay, so for quality of traffic, quality of service basically has to do with how the network traffic is being queued and received, also shaping the traffic. And last but not least, it provides the function of automated controls for open flows and some other protocols for management, basically. So this is how the virtual switch basically is managed using the Open vSwitch. So Open vSwitch basically helps to manage virtual switch with virtual machines through the Open vSwitch. Then we have the distributed switch. Distributed switch, from the name, in this case, it's a virtual switch, basically, that can help to communicate with virtual machines that are on different physical machines. So for example, this is a physical machine called host machine 1. This another physical machine, host machine 2. This another physical machine, host machine 3. So you can have your virtual machines, which are the guest machines, guest machine, guest machine, residing on different distributed virtual environments of different host machines. So you will need a NIC, okay, which is a virtual link, virtual link, virtual link, to be able to communicate with this virtual switch, and reroute the traffic so that the different virtual machines that are on different physical machines can be able to communicate. Important thing to list here is that you need to have different virtual NIC that will communicate with the switch for different virtual machines that are on a distributed environment to communicate with each other. So question before we go to the last section. Question.
No questions.
Okay, so let's look at the next section, which is the last section. I believe this section will be very brief. We have network features of Huawei virtual products or visualization product. We actually mentioned one of the Huawei's visualization product, which is a hypervisor in the last class. You can remember the name of the hypervisor the Huawei is using. Virtual machine monitor or virtual machine manager, or we can call it hypervisor, that is used by Huawei. Who can remember? Yeah, so this is the name, Fusion Compute. Okay, so now this is a virtual machine manager or hypervisor that is being used by Huawei and Huawei devices. So there isn't much difference from the base concept that we mentioned. You have a physical switch, you have a host machine, you have another host machine, and you will need a virtual switch, okay? And this virtual switch, you can create VLANs, different group of VLANs on it, and then you can have your virtual machine. This is a virtual machine with a guest operating system. In this case, it's a Windows. And of course, this one also have a guest operating system, which is a Windows. The third one is a guest operating system, which is a Red Hat, basically. Also, in the second physical machine, which is the host machine too, you have a Red Hat operating system as the guest operating system, and you have the Windows and another Windows on the other two virtual machines. Now you can see that all these are connected through a NIC. So you have a NIC, and the NIC is connecting to another virtual NIC, okay, on the virtual machine. So this is the virtual machine basically. So you can have group of port groups, okay. Let's say this is a VLAN, okay. You create this VLAN 100, VLAN 200, VLAN 300, and you can simply create your virtual machines on the different on the virtual LANs, which are on the virtual switch. Okay, so you can have your uplinks, okay, are sending information from the host machine, that's the physical machine, to the switch, okay, and this information can go to any of the virtual machines and vice versa. So this is the same concept that we explained, but now this concept is explained in relation to the fusion compute hypervisor that Huawei is using basically. So what if this information from, let's say, the Red Hat in this physical device want to send information to the Red Hat in host machine 2. Now let's look at it one after the other. This information or traffic will be sent through the NIC and or to be precise, a virtual NIC. Okay, so the virtual NIC send the traffic to another virtual NIC on the switch, okay, through the LAN or VLAN, VLAN 100, and then basically it's sent to another NIC, which sent to a physical NIC in this case. So this is a physical NIC, which is on a physical machine, okay, which is the host machine. And then that means that the traffic simply goes to the physical switch, layer 2 switch. So the layer 2 switch will have to send the traffic, okay, to the NIC in host machine 2. This is a physical machine, and this is also a physical NIC. And then this physical NIC will send the traffic to a virtual NIC in the virtual switch. And this will send the traffic in turn to the VLAN, okay? And another virtual NIC will receive it, which in turn send the traffic to a virtual NIC on the virtual machine. This is the virtual machine. And then this virtual machine simply is being run by a Red Hat Linux operating system. And then, of course, this information can go from the lower layer up to the application layer of the Red Hat and vice versa. So this is the situation in the fusion compute network architecture. So yeah, so I explained it. I didn't even know that it's already drawn here. So, but this drawing shows the flow basically. So we can have exactly what I explained now. So this is the virtual machine. Red Hat is sending information to this Red Hat. So you can see the flow of traffic. It goes through the NIC, okay, to the virtual NIC, to the physical NIC, to the physical switch, and then to the physical NIC on the host machine, to the virtual NIC, to another virtual NIC on the virtual switch, and then to another virtual NIC basically in the virtual machine before it gets received by the guest operating system, which is the Red Hat. So you can look at it in different ways. If it's a communication between the Red Hat and the virtual machine that contains the Windows operating system, but within the same physical machine, which is the machine host machine. Simply, it can send the traffic to the NIC and to another NIC on the virtual switch, okay, and then to, of course, another virtual NIC on the other virtual machine that contains the other operating system, and then they can communicate with one another as the case may be. Yeah. Yes, so last but not the least, we have security guards, which are mostly that helps to communicate between virtual machines that contains different types of guest operating systems. So for example, you have a Windows operating system and a Red Hat machine, which is the Linux, okay? So basically it has to pass through 3 different layers of security guards before communication can take place. And if there is any of the rules that the communication actually did not allow, It's not allowed. It simply means that the communication between the two machines cannot actually hold. But it's easier when you have uh, two virtual machines that have the same virtual guest operating system. So that means that the rules are easier simply to comply with, and the communication can be more seamless. But in case of two different guest operating systems on two different um, virtual machines, it means that all the three rules have to be complied with before the security group can allow communication to take place. So lastly, that's it. Any question? I would like to have your
Thank you,
attention
Doctor.
so that we can try this quiz question together. Which of the following falls into the category of north-south traffic? A. Traffic between virtual machines in a data center.
B and D.
B. Traffic generated when users access the data center through the internet. Is this correct?
Yes, and D also.
Okay, let's see what happened. C say traffic generated during virtual machine live migration. And then lastly, we have traffic between virtual machines in different data centers. In different data centers. Traffic between virtual machines in different data centers. You said B and D is correct?
Yeah, B and D.
Okay, let's try the second question. B and D correct. Question number 2. One virtual machine can have multiple virtual links connecting it to different virtual switches. True or false?
True.
Can you have multiple virtual links on the same virtual machine? Mohammed?
I'm not sure. I'm trying to remember if we've done this before in general.
Yeah. So we actually did it. Okay. So this is, for example, this is a virtual machine. Okay. These are the two links. This is a virtual link and this is a virtual link. So this answers the question. On the same virtual machine, you can actually have multiple virtual links. And these virtual links, they can communicate with different. This link is communicating with this virtual machine, and this link is communicating with basically another virtual link on a different virtual machine. Yeah, this actually explain it. So actually, the answer is so on the same virtual machine. Okay, one virtual machine can have multiple virtual links, connecting it to different virtual switches. Yeah, that's true. Oh, now this is another thing that I need to look at. They said different virtual switches. Different virtual switches. Yes, we can have multiple virtual machines on the same virtual links on the same virtual machine. But is it connecting to different virtual switches? Different virtual switches. Who have an idea? Because here we have actually one virtual switch. Okay, so if we create a different virtual switch, yeah, it's okay. A virtual switch is simply a segregated switch. Yeah, it's okay, we can have. Sure. So it still goes through. Yeah, it still goes through. Positive. Sure. Okay, any question? So summary of the chapter. In this chapter, we cover basic knowledge about physical and virtual networks used in visualized environments. This is what we discussed throughout, how virtual machines basically communicate in a cloud environment. And we look at the different type of segregation methods that this has to go through. What are the uh, things that helps the virtual machines to communicate with each other? We mentioned it's a virtual link and a virtual switch, of course. And then we discuss about north-south traffic and east-west traffic, basically. So these are the important things. Recommendation, you can look at these links for additional information on this chapter and also on this, yeah, on this course altogether. Thank you for listening.